Hello, this is my video response assignments regarding the topics of ductility, brittleness, and toughness. I started out my learning experience and to understand the relationship between stress and strain and the ability for material to resist applied force without any kind of yielding or fracturing. Its compression or tension test is required. These tests helps us to plot and graph the stress and strain curves. Furthermore, I understood that the stress and strain curves can be classified into three groups depending on the material. The first one being ductile materials, where it exhibits or shows both elastic and plastic behavior. The second one being brittle materials, where it predominantly shows elastic behaviors. And the last one being viscoelastic material, where large elastic deformations is expected. After understanding the three different types of the elastic stress and strain curves, and now I'm able to find different properties from the stress and strain diagrams. The first one being proportional movement, which is the greatest stress that can be developed in the material without causing any alteration of the law of the Hooke's law. Second one being elastic movement, which is the maximum stress that can be developed in the material without any kind of plastic deformation. The third one is a yield point, where the stress at which the material deforms without any increase in the stress. The fourth one being the ultimate stress, which is the maximum stress that is developed in the material determined from the original cross-section. And the last one is the fracture strength, which is the stress at which the material breaks or fractures. Furthermore, after understanding the stress and stress diagrams and the types of classifications, I understood that there's another type of stress and stress plot named true stress and stress graph, where it shows more extensive details and more extensive results. These diagrams are plotted by using the instantaneous areas and lengths. I also learned the respective formulas of the true stress and the true strain. After finishing understanding the true stress diagram and the stress strain engineering stress strain diagram, I went on to understanding and defining ductility and brittleness. Ductility is defined as the capacity of the load resisting material to undergo a large plastic deformation, where it shows a large deformation, where the brittleness is the opposite, where the tendency of the load resisting materials to break, where small deformations is occurring. Furthermore, I went on to understand that the energy absorption capacity during plastic deformation is known as toughness, as the amount of energy that can be absorbed by the unit volume of material, and this can be named as the modulus of toughness. I also learned its respective formula, while I also learned that the resilience is the energy absorption during elastic deformation, not during plastic deformation, and this is what the difference between toughness and resilience. Of course, they have the different formulas for each one. After finishing all of these, I went on to understanding that when a material is defined as the maximum stress that can be developed of causing more at a specified permissible strain, this is known as the yield stress, and it can be found either from the stress strain graph or from using the method named offset. Lastly, I went on to understand that the hardness of a material is defined as the resistance of a material to identification and can be tested by three different methods. The first method being the brittleness hardness, where the load is being pressed for 30 seconds and the diameter is measured. But the second one being the Rockwell tests, where it's similar to the brittleness test, but in this time the diameter is not being tested, the indentation depth is measured. And the last one is Vickers hardness, where instead of a sphere, a conical shape is used. So thank you everybody, this is my video response assignment regarding this topic. I hope I covered every single point and summarized it as fast as possible.